Imagine that you are a nail and you're going to be hit with a hammer. So this is a picture of you, you're the nail, I don't know what your mass is, and you're sitting there with velocity 0, and then the hammer hits you, and after the hammer's hit you, you'll be going downwards with a velocity of v. Now, let's actually just label this nail so that we know whether we're the nail or the hammer. So if we're the nail, it doesn't matter which way we choose to be positive or negative, but when you're looking at an impulse, then it usually works out best if you choose the direction in which you feel the impact or the tug. So if I'm the nail, then I feel myself being pushed downwards by the contact with the hammer. So I'm going to take that to be positive in all my equations. Now, impulse is change in momentum, so that's the final momentum minus the initial momentum. In this case, m times v is the final momentum, and m times 0 is the initial momentum, giving us an impulse of mv. Not very helpful. We don't know what the mass of the nail is, and we don't know what the velocity of the nail is after the hammer strikes it. However, what we can do is we can look at the impulse on the hammer, because that will be the same as the impulse on the nail, but in the opposite direction. So now I'm the hammer. Now when I'm the hammer, I'm going down quite happily through the air, not being restricted, and then bam, I basically feel myself being hit in this direction by the nail, essentially. That's what I feel. So imagine yourself as one or the other, and then think in which direction do I feel the impulse, and then choose that direction to be positive. Okay, so for the hammer, before it's 12 kilograms and it's going down with a speed of 8.5 meters per second, and then afterwards it's still 12 kilograms, but it has come completely to rest, and that's happened in 0.008 seconds. So impulse and change in momentum, mv minus mu. In this case, we've got a mass of 12 and a velocity of 0 as our final mass and final velocity, minus, and now we've got a mass of 12 and a velocity, the initial velocity, now this is 8.5, but notice this direction is the opposite of the direction we're taking as positive. So this is a negative velocity with this as positive. So it's actually 12 times minus 8.5. which is, if I get my calculator, 12 times 8.5 is 102, and the units is Newton seconds. So the impulse on the hammer in the positive going upwards is 102 Newton seconds, so the impulse on the nail going downwards is 102 Newton seconds, because it's the same impulse. As for the magnitude of the force acting on the nail, well, we can use what we know about impulse being force times time. So the impulse on the nail is the force acting on the nail multiplied by the time that the force acts on the nail. And we have to be really careful which direction we're going in here. If I'm the nail, here's me as a nail, then I feel the force going in that direction. So I'm going to take this direction to be positive. Now if I'm the nail, don't forget we now know that this is actually 102 Newton seconds downwards. So if this is positive, this is 102 Newton seconds in this direction when I'm the nail. Here I'm the nail as well. I'm taking this to be positive. So the impulse is 100 in that direction. The impulse on the nail is 102 Newton seconds. We're trying to find out the magnitude of the force, but we know that the amount of time that this force acts on the nail is 0.008 seconds. So 102 over 0.008 is the size of the force, the magnitude of the force, which is 0.0812750, and the unit is newtons. Now, in this question, I had two significant figures here, only one significant figure here. I'd probably, in an exam, give my answer to two significant figures as well, 13000 newtons as my final answer, like that. Let's try this really similar example. I'm not going to imagine myself as the golf club in this situation. I'm just going to imagine myself as the ball. Here I am. I'm the ball, and my mass is I should have made a bigger ball, 0.045 kilograms. And before, I'm just sitting there, I'm not doing anything, so I'll just put a velocity of 0. And then afterwards, I'm still 0.045 kilograms, but now I'm heading off with a speed of 45 meters per second in that direction. So I am the ball. Now, if I'm the ball, then I feel myself hit from left towards the right. So that's what I'm taking to be positive in my equation. Impulse is change in momentum, final momentum minus initial momentum. Our final momentum, mv, is the mass, 0.045, times the velocity, 45. Always think about direct positive or negative. This here is going in the same direction as positive, so this is positive. Then we subtract the initial momentum, which is just 0 times 0.045, so that is 0. So we get mass times velocity, which is positive, minus mass times velocity is 45 times 0.045 is 2.025 Newton seconds. Don't forget the units on that, and usually I would give that to 2 significant figures in my final answer. And so that's 2 Newton seconds. Okay, what is the force exerted on the ball by the golf club? So we're the ball still, and the impulse is going to be equal to the force times the amount of time it's exerted. And we know that the impulse for the ball, so that's going from left to right, is going to be 2.025 Newton seconds, not using a rounded version here. And then the force, not in subsequent calculations. The force is what we're trying to find out, and the time is 0.0035. So if we do 2.025 divided by 0.0035, then we get F equals 578.57 blah blah blah. So to 2 significant figures, 580 newtons is the force, average force exerted on the ball by the golf club. Most important thing, make sure you're getting these arrows fixed right at the beginning. Which way is positive? One more example. This looks more complicated, but actually it's easier, because what is the big thing that's really, really important? Think about which direction is positive, and then stick to it. In this case, because we're dealing with vectors, the directions are already implicit within the vector. It says how far left and right, how far up and down, how far left and right, how far up and down. So we don't need to think at all about directions. Woohoo! Because that's actually the hardest bit. Okay, so let's just go straight in with our equations. Impulse is change in momentum. In this case, we've got a mass, here's initial. We've got a mass of 8 kilograms and a velocity of 2i plus 2j. That's our initial velocity, our initial momentum. And then our final momentum is a mass of 8 kilograms still and a velocity of 6i minus 4j. Let's put them into our equation. The final mass is 8 kilograms and the velocity is 6i minus 4j, minus the mass at the initial point is still 8 and the velocity is 2i plus 2j. So if we tidy all that up, we get, 48i minus 32j minus 16i minus 16j, which gives us 48 minus 16 is 32i and minus 48j, and that's the impulse. But impulse is force times time. So if I just make myself a little bit of room here, I can take that impulse, 32i minus 48j, and use the equation that impulse is force times time. I know the amount of seconds, it's gone from t is 0 to t is 4, so 4 times the constant force acting is 32i minus 48j, and so dividing both sides by 4, we get 32 divided by 4, 8i minus 12j, and that's the constant force acting on this particle. So you've got this particle, it's got a velocity of 2i minus plus 2j, it's going in this direction, and I apply a force, and the force is going in the direction 8i minus 12j, so that's kind of, what does that look like, 8i that way and then 12j. The force is sort of in that direction, probably be a push like this, and then that is what causes the particle to change its velocity, change its momentum, and end up going over here. So, key points. 1, really important, unless you've got vectors, in which case, hooray, which direction is positive? And you make a note of that. And you keep checking that your velocities are having the right sign on them. So put a little arrow somewhere and say, that is my positive direction, and then keep, whenever you're doing a velocity, look at that and check whether that means your velocity is positive or negative. The next thing is your picture. You have a before picture and an after picture, and we're deliberately going to do them one above each other like that. If you want, you can write before and after. You put the mass inside, and then either above or to the side you put an arrow indicating which direction it's going in, with the speed at the top, v1, v2. If you don't know the speed, you just put a v or a w, something like that. With impulse, impulse is change in momentum, and that is mv minus mu, being very careful that m and u have the right signs, but it's also force times time. Impulse is also the force exerted on the particle multiplied by the amount of time. The units is Newton seconds. Newton seconds is the units. When you're calculating impulse, when you do your direction, pick the direction to be positive that the particle is feeling the impulse. So you choose which particle you are, it doesn't matter which because it's the same impulse on both, and choose which one you are, imagine being that particle, and then that particle is the one whose mass goes here and whose initial and final velocities go in here, and that particle determines the direction you take to be positive. And always choose the direction to be positive, which is the direction in which that particle would feel the impulse.